Hi guys, welcome to Piece of Code and welcome to this video. So in this video we're going to continue our Java OCA crash course series, and this is the 31st episode, or you can say 31st lecture in this series. And this video we're going to discuss what we learned in chapter 4, which was methods and encapsulation. We learned a lot of stuff in this chapter, right? Like how to design method, how to work with varags, how to apply access modifiers, passing around data within methods, overloading methods, constructors, and some simple lambda functions, right? We learned a lot in this last series of videos in chapter 4. So this video will serve as a summary to the chapter, and also we're going to discuss some important questions that you can get or expect from this particular chapter. Alright, so let's move on, guys. First of all, let us talk about the summary. So these are all the important points that you need to cover from this chapter. You need to remember. First of all, be able to identify correct and incorrect method declarations. Alright, so you have to be very aware of all the correct and incorrect method declaration. For example, we discussed something, right, that in a method the return type and the method name and the list of parameters, for example, should be in the same sequence. Other things like access modifiers and like the public keyword, the static keyword, and everything can be in different sequences also, that is fine, but these two things should come like this, right? So you need to be able to figure out, okay, this is a valid method declaration or it's an invalid method declaration, right? Because you will get scored on that, you'll get questions on that in the exam. Identify when a method is or a field is accessible. I mean, recognize when a method or field is accessed, when the access modifier like the private, protected, public, or default allow or doesn't allow it, right? You have to remember that what is the scope of each access specifier, and they may try to play around with that particular fact, and they may design questions based on that. Recognize valid and invalid use of static imports. So static imports import static members, as I've told you, and they are written as like import static and then the particular method, static method, or somewhere where it is present, right? We have to write it like this. So this is how you use the static import. So make sure that your static import format is in the right order and something like that. Okay, so that is it. State the output of code involving methods. So there will be a lot of questions regarding methods. Sometimes there will be static methods calling non-static methods, and there would be some non-static methods calling static methods, right? You should be able to figure out which is valid and which is not, and I've discussed this in detail in my previous videos, so you can have go and have a look at that, okay, because it is very, very important. Evaluate code using constructors. Make sure you understand when to use this keyword in the constructor, what is constructor chaining, and something like that. We have discussed that in detail. Questions will be revolving around that, so make sure you remember what constructors are and what is a basic fundamental property of constructors, right? Be able to recognize when a class is properly encapsulated, right? So look for private instance variables and public getters and setters, right? They may also ask questions like they will give a class, for example, right, and they will have some members like instance variables and instance methods or some static methods there, and they will try to like ask you the question if it is a valid encapsulated class or not, okay, and you should be able to recognize that. So that's that. And then at the end, write simple lambda expressions. So look for the presence or absence of optional elements in the lambda code. I have discussed that lambda code something looks like this, right? For example, then something like something. This is some example of lambda code, and I've discussed what element of a lambda code is optional and what is mandatory, and the exam may try to trick you in some mandatory and non-mandatory or optional fields of a lambda syntax, right? You have to be able to figure out if it is a valid lambda syntax or not. That is one thing. And also have a look at the predicate interface, right? That is an inbuilt functional interface that is provided by the Java itself. It has one method, that is the test method, and it will return a boolean value, right? So you can use the ready-made predicate functional interface if you want to use functional interface as part of your code, right? So yeah, that's it, I think, about the summary of chapter 4. Let's move on and see some questions from this particular chapter. So let's look at this question, guys. Question number 1. Which of the following can fill in the blank in the code to make it compile? Okay, choose all that apply. So it's obviously, first of all, you need to figure out that if it is a multiple choice question or not. If you go for one choice, then the mark is gone. So yeah, so it says public class ant, and then we start with a method, and it says what can we fill in this particular space to make it compile. Okay, so if I read through the options, I would say that B and C are the correct options in this case. Why? See, first of all, void is a return type, right? Only the access modifier or optional specifiers are allowed before the return type. Just now I discussed that you have to be very sure about the structure of a method, and in a method the return type and the method name and the list of parameters, this come in sequence. Other than that, whatever you want to place, you can place it before the return type in any order that you want. So final can come, it's a keyword, it can come over here, it can be a final method, and private is an access modifier which can come over here. So these are all valid, right? So default access does not require a modifier, so default is not going to work in this case. Public, it has a capital P, it should be small, so it's not going to work, it's not a keyword in this case. String is another return type, but it already has a return type, so a method cannot have both return types. And ZZZ doesn't even make any sense, so I'm not going to go with that. It's completely nonsense. So I'm just going to go to the next question, guys. Which of the following compile? It just says you have to find out which of the following statements compile. So if I read through the options, guys, I would say A and D are the options which compile. Okay, these are correct because the optional specifiers are allowed in any order, first of all. So it can be static final or final static. So this is cool. So static final, it is fine. I have already told you that void, this method name, list of parameters, and these are all should be in sequence, but before the return type you can use any kind of keywords in any order, right? So that should be fine. Option B and C are incorrect. Okay, first of all, because they have two return types which method cannot have, first of all, because it has an int and a void, and then a void and an int. Doesn't make any sense. This E, as I've already told you, that void comes before the final. Final should come before the void because return type and method name should be in sequence. So it is not, so I'm not going to go with that. Void public method, still the same scenario, so I'm not going to go with that also. Okay, I hope this is clear, guys. We have done 2 questions regarding method declarations, so make sure you know the order in which the method declaration work. Okay, because a lot of question may come into the exam, and if you are not sure about the method declaration, then you will lose a lot of marks, guys. Question number 3 says which of the following methods compile? It's also some kind of a method declaration or a method structure question, and if I read through the options, I would say that A is the correct option, second one is C, it is the correct option, and D is the correct option. I would go with that. Okay, so first of all, B, right? Why B is not correct? So B and G, if you see B and G, they are returning null, right? Because null requires a reference object as the return type. So void is not a reference object since it's a marker for a no return type, right? Void means nothing at all, right? So it's not going to work. Void just literally means that you are not returning anything, right? But you are returning a null, which is an object reference. Object can point to a null value. So I'm not going to go with B in this case. So G is also not going to work because it is returning null, and also the return type is int. So we should have to return a number in this case. So it is not returning, right? E says public int method E, but it is returning a precision type value, which is a decimal type value, or also floating type value, but it is an integer. So I'm not going to go with that. It says int, but it only says return over here. We have to return an int over here. So it's not going to work, guys. Not going to work. So I'm not going to go with that. So A, C, and D are the correct options. Talking about question number 4, guys, it says which of the following compile, and if I read through the options, guys, I would say A, B, and G are the correct options. Now options A and B are correct because the single var parameter is the last parameter declared. I've already told you that if you have a var parameter like this, it should be either the single one, it should be only the only parameter in the particular method, or if it has multiple parameters, then it should be the last parameter. So in this case, A has one parameter, B has two parameters, but the this var is at the end, and G, it's fine because it is associated with two arrays. Now two arrays are fine, but if you are using a var parameter, it should be at the end or it should be a single parameter. You can have multiple arrays, right? This is a string array, this is an integer array, something like that. But if you have a var parameter, it should be either the single parameter or it should be at the end. I have already discussed that in detail in my other videos. You can go and have a look at that. Okay, options C and F are incorrect. Okay, C and F are incorrect because if you see, the var parameter is not last. Option D is incorrect because two var parameters are not allowed in the same method, so it's not going to work. And if you see, option number E, if you see, is incorrect because for var, so if you see this particular E, right, this is invalid. That's what I'm trying to say. It should be like this, right? So that's why it's not going to work. Alright guys, so I hope this is clear. Let's move on to the next question, question number 5. Alright, so it says, given the following method, which of the method calls return to, choose all that apply. Okay, it's a pretty simple question guys, easy one. You can pause the video and have a look at it. But if I read through the options, I would say that the correct options are D and G, right? Why? Because option D, okay, it passes the initial parameter plus 2 more to turn it into a var array. Okay, I hope that is clear guys. So if you see, this one is boolean, so this true is going for that, and these two are going as var parameters. So when I say b2.length, I'm getting 2 as the length because there are two true values inside this var parameter. So I hope that is clear guys. Okay, now option G passes the initial parameter plus an array of size 2. So this is true, fine, this is coming for this boolean, but this is a new boolean array of size 2. Now if you have a var parameter guys, you can also pass a array to it because var are basically arrays only, but we just write it like this, right? It's a good thing to write like that. So it can accept arrays, right? That is the rule. So if I pass a boolean array of 2 size, right, then if I say b2.length, then there are 2 elements in this particular var array, so we'll get 2 as the answer, right? I hope that is clear. Now option E and F do not compile because they do not declare an array properly, so I'm not going to go with that because this is not the way you pass in an array like brackets and stuff. You have to do more than that. Now option number A, first of all, is not going to compile because it is accepting 2 parameters, but you are not passing any parameter. Option number B also is not gonna, if you say option number B, creates a var array of size 0, because if you do not pass anything inside the var array, it's basically you are passing an empty array which is a size 0. So it's not gonna work, it's not gonna display the required output that we want. And option number C is only passing, if you see over here, it is passing a true for this boolean variable, and it is passing another true for this var parameter, so it will return 1 in this case, so it's not gonna work. So C is also not gonna work. So D and G are the correct options guys. Okay, I hope that makes sense guys. Alright, let's move on to the next question, which is question number 6 guys. It says, which of the following are true? You have to pick out some correct option from this particular question. So if I look through the options guys, I would say that the correct option in this case is D. It says you can use access modifiers to allow read access to all methods but not any instance variables. Now why is that? Now this is a common implementation for encapsulation by setting all the fields to be private and all the methods to be public. Okay, that's a common mechanism, because when we use encapsulation, we make all our instance variables private and then we have public getters and setters. So that is the common implementation. We have already learned about that in detail in my previous videos. You can go and have a look. So A says package private access is more lenient than protected access. So it is incorrect because protected access allows everything that package private access allows, and additionally allows subclasses access. I mean, if you have a child class in some other package also, it is accessible. So it's not going to work in this case, guys. It's incorrect option. B says a public class that has private fields and package private methods is not visible to the classes outside of the package. Now it is incorrect because the class is public. First of all, this means that the other classes can see the class, however they cannot call any methods or read any fields because they are private. So not gonna work, it's incorrect. You can use access modifiers, so only some of the classes in a package see a particular package private class. See option, this is incorrect because package private access applies to the whole package, right? So it's not gonna work. Some of the classes like this is not the case. Like in it's actually you can achieve this particular scenario in Java 11 onwards, JDK 11 onwards, after the inclusion of modules, right? Because in the case of modules you can exclude or include some classes and you can make them visible, right, as a module. So that is a different case, but in this case it is not possible like this. Okay, so you can use access modifiers to restrict read access to all classes that begin with the word test. Still it is not possible like that, guys. It's just either you apply it to the whole package, like if you apply it to a class, then it goes for the whole package and something like that, right? You cannot be like specific like this. Same you can do in the case of modules in JDK 11, but it's not possible as of now in this case. Okay, alright, so question number 7, given the following my.school.classroom and my.city.school class definitions, which line numbers in the main method generate a compiler error? Alright, so by reading through the code and going through the options, I would say that the correct options are B, C, D and F. So first of all, why did I choose these options? So first of all, the two classes that you see over here, that is the classroom class and the school, are in different packages. So which means private access and default access will not compile. So default access is also known as package private access, because only in the specific package you will be able to access those fields, right, which are marked as default. And also protected access will not compile, since school is not inherit from classroom. So this school is not the child class of the classroom, right? So protected is also not going to work, and private is also not going to work, and any what we call default access is also not going to work. The only thing that is going to work is this particular public access, because public access, using public access, you will be able to access the variable or method in different packages also. It is basically public to all. So that is why line number 8 will compile fine, because floor has public access, so it is going to be compiling fine. So except that, all of the options will not compile. Okay, so I hope that is fine. I hope that is pretty easy question. You will be able to do it. You just have to pay attention to all of these access modifiers and stuff in the exam. Question number 8, guys, it says which of the following are true, and these are the options, and if we see through all of these options, I would say that B, C and E are the correct options in this case. So let us read through the option. First of all, encapsulation requires using methods to get and set instance variables on other classes. We use getters and setters, right? Because in encapsulation the fields are private and are basically our methods, the getters and setters, are public, right? Because that is an abstraction phase in encapsulation that we use to to prevent unwanted modification to our instance variables. So that is fine. B is the correct option. Encapsulation allows setters, I just discussed, and immutability uses private instance variables. Okay, so basically immutability takes this step further, allowing only getters, so the instance variables do not change state. So basically in immutability what happens, like in the case of string, like string is an immutable class, right? So if I say string s equals to Akash, right, and then if I append something to it, then basically a new string will be returned. So we're not able to change the state of the current object, but instead of that we are returning a new instance altogether. So that is immutability. So immutability takes it a step further. That is why B, C and E are the correct options in this case, right? I hope that is making sense, guys. So question number 9, which are methods using Java Beans naming conventions for accessors and mutators? So accessors and mutators are nothing but getters and setters. So if you see through the options, I would say that C and E are the correct options. So if you see public int get num wings, so if for example let's assume that the variable name is num wings, right, and it's an integer variable, so get num wings is correct and the return type is correct, which is integer, and it is returning it, so that is fine. So basically, you know, in getters and setters the convention is set the variable name and then get the variable name, and if you are using the boolean, then the getter is the variable name and then the set the variable name, right? So in this case get num wings is fine. Public void set can swim, it is fine. So can swim is a boolean variable, so boolean b it is accepting, and can swim equals to b, which is fine. So this is okay. Public int num wings is not fine, there is no set over here, not gonna go with that. Public boolean can swim, it's not gonna work, as I've just told you, we have to add is over there. And get can swim is also not gonna work because there is no is over there. So properly think about the naming conventions of getters and setters, and also I have explained it in detail in my previous videos in the chapter 4. Please go and have a look at it. Question number 10, guys, it says what is the output of the following code? And basically if you see through the code, there is a package, there is a class rope, and there is a static block over here, and the static int length equals to 5, and we have a method void swing, it just print something, and then there is another we import this rope, and then we import static rope dot star. Okay, so it is doing some stuff over here, and then there is this code. Okay, so by looking at the code and by looking at the options, I would say that the correct option in this case is B, okay, which is swing 10 in this case. Okay, so how did we go over here? So if you see over here, rope runs line 3, setting length to 5. Okay, now this particular thing, now what did I say, what did I mean by when rope runs line number 5? Basically this is a static variable. So I have already told you that when it comes to static variables and stuff, it gets initialized when the class itself gets initialized in the beginning. So that's it. So the static int length equals to 5 gets initialized over here whenever the rope class is initialized, right? I hope that is making sense. Then immediately after that runs the static initializer block, which is over here, right? Static initializer block. Now in this case the length is set to 10. Okay, now line number 5, now which line number 5? This particular line number 5, if you see, this line number 5 calls the static method normally, right? If you see over here, this line number 5, it says rope dot swing. So this is a static method and it normally calls like that, right? And it prints swing because in this system.out.print statement we are printing swing. I hope you are following the code, guys. If there is some issues, then please you can go back and listen it again, or you can just pause and try to understand the code by yourself. Alright, now in line number 6 also calls the static method, right? If you see over here, and it is a valid call because we can easily call or fetch a static method or static variable using the object of the class. It is completely valid. There is no compilation issue there. Okay, because Java allows calling static method through an instance variable. Okay, so that is why swing and another swing is printed. That is fine. And then after that we have a reference to the length variable, which is this one over here, right? So we are trying to print the length variable, right? And how can we print the length variable? Because we are using a static import over here and we are importing all the static stuff, right? So length is also present in this particular class. So what is the value of length now? In the static initializer block we had changed the length to 10. So that is why we are printing 10 over here. Okay, I hope that is clear, guys. This one is not going to work according to the explanation. It is not going to work, and there is no compilation issues, so you don't have to go with any of those options. I hope that is making sense, guys. Yeah, that's it. Let's move on to the next question. Question number 11. Which are true of the following code? Question number 11. So let's read through the code once we have this class rope over here, then we have a void swing over here, and there's a static method over here, and then there is a instance method over here, and then there is public static void play, and we are calling these two methods with the swing and climb. Okay, then there is a instance of the rope, then rope dot play, rope equals to null. We are setting the instance of rope 2 to null, and then we are calling this rope 2 dot play. All right, there's some stuff happening over here. So what is the correct option in this case? I already figured out what it is, and I would say that the correct option in this case is B and E, and there is exactly one compiler error in the code. All right, and E says if the lines with compiler errors were removed, the output is swing. Okay, why is that the option in this case? See, first of all, line number 10 does not compile. This line that I have marked over here, it doesn't compile. Why is that? Because static methods are not allowed to call instance methods. First of all, I've already explained that in detail why it is not allowed. You can go and have a look at it. You can call a static method inside a instance method, but you cannot call an instance method inside a static method. The opposite is not true. So this is going to throw a compiler issue, so it's not going to work in this case. Okay, now even though we are calling play, all right, even though we are calling play over here, right, we are calling play as it were an instance method and an instance exists, Java knows play is really a static method and treats it as such. So because Java allows you to call static methods using instance variables. Now one more thing to keep in mind, guys, in this case, and many people will get confused, is that if you see this line, it says rope 2 equals to null. So basically rope 2, which is a reference to an object of rope, which is a object reference variable, which is rope 2, it is pointing to null. So many people will get confused and will think that if you say rope 2 dot play, it will throw a null pointer exception, but that is not the case at all. Okay, because Java allows you to call the static methods. This play is a static method. If you see, this is a static void play. If it had been an instance method, then this would have thrown a null pointer exception, because instance methods depends on the objects first of all, right? I have already told you that. But in this case, rope 2 equals to null, even though we are setting the reference variable to null, still it is a static method and it is associated with the class, not with the object. So even though the object is null, we can still call using this syntax and it will execute fine. So there is no issues in over here. There is no compiler error or any kind of runtime error associated with it, right? So if everything would have been fine, if this compiler error is removed, then basically we will be able to print swing 2 times, because if we call the play method and this one is removed, play method in turn calls the swing method and we will print swing 2 times, because we are calling play once and play second. Okay, so that is why B and E are the correct options. I hope that is making sense, guys. Other options will not work in this case, guys. You can just ignore them. Alright, let's move on to the next question, guys. Alright, so what is the output of the following code? There is this rope swing class, and then there is this rope class. There are some instances of this rope class getting created, and we have this main method. Alright, so by looking through the code and by looking through the options, I would say that the correct option in this case is D, which is 8. 8 will be the correct option or answer, you will say. Now here there are 2 important details to notice in this code. First, note that rope swing has an instance initializer and not a static initializer. Over here, if you see, you will be able to notice over here. Since rope swing is never constructed, the instance initializer doesn't run at all, because for rope swing there is no object of rope swing constructed. So an instance initializer always runs when you construct an object of that class, right? It is different from a static initializer block. Whenever the class gets initialized, the static initializer block gets initialized. So that's the difference between the two. so it doesn't run. The other detail that the length is a static one. So if you see, this length is a static variable. So at the end, if you see, we are setting the row 2.length equals to 8. So no matter how many objects you create, it will be global for all the objects, right? Because it doesn't depend on the actual object itself. The static variable, if you modify it once, twice, thrice, or I don't know, 10 times or a million times, it will reflect in all of the objects because it is associated with the class. I've told that millions of times. That's why the option is 8 in this case, because here it is modified to 8. Alright, so I hope that is making sense, guys. Let's move on to the next question. Question number 13. So in this case, how many compiler errors are in the following code? So there is some code written over here. There is some static final string left rope, static final string right rope, and there is the static final string bench, static final string name equals to name, and then there is this static initializer block, 2 blocks, and then there is this main method. Alright, so by reading through the options and the code, I would say that the correct option in this case is E, which is 4. See, static final variables must be set exactly once. Okay, so it must be in the declaration or in a static initialization block. You cannot declare a static initialization block first and then initialize it again. Then that doesn't make any sense of using a final variable, right? A final variable should be set only once. You cannot set it multiple times, right? So line 4 doesn't compile because bench is not set in either of these locations. So this is line 4. So we are not setting bench at any places. So you have to set it, right? But it is not set at any point. So that is fine. It doesn't compile. Line 15, if you see over here, doesn't compile. Line 15 doesn't compile because final variables are not allowed to be set after that point. Okay, it can be only set while declaration or in the static initializer block. Now line 11 also doesn't compile because name already has been set once. Okay, so we have already figured out 3 over here. And line 12, if you see over here, it doesn't compile. Over here, if you see, line 12 doesn't compile because right rope is set twice as well. Because if you see over here, we have a right rope set over here and we are trying to set the right rope again over here. So if you see, 1, 2, 3 and 4 are the compiler errors that you're going to face in this particular code. So you have to be very, very careful while detecting these because you have to be very, very careful about the concepts, guys. And in this case, the only concept that you need to be careful about is that final variables can be set only once, either during the declaration or during the static initializer block. Okay, I hope that is clear, guys. Let's move on to the next question. Question number 14, guys. And one more correction, not only final variables, static final variables. It is static over here. Okay, I hope that is making sense. Now question number 14, if you see, which of the following can replace line number 2 to make this code compile? Okay, so we have to replace line number 2, and basically there is some import statement that need to be put in that particular place to make this code compile. Okay, then we are using this array list over here, and then we are using the sort function, and we are passing in the array list inside the sort function. So that is it. Now which are the correct options in this case? In this case, I'm going to say that the correct option is B, right? Now there are two valid ways to do this import, right? This import operation, we can do it in two valid ways. One is import, if you see, import static java.util.collections.star. We can do that. Otherwise, we can, instead of using the star, we can exactly import the sort method, which is this static method, right, which is present in the collections interface. Now option A is correct. Sorry, not correct. Option A is incorrect. Option A is incorrect. Sorry, my bad, slip of the tongue. I have already marked B as the correct option. Now option A is incorrect because you can only do a static import on static members. Okay, you cannot do this stuff like normal import. So A is not going to work in this case. Now as I've already told you, B is one of the options. We can do import static java.util.collections.star, or exactly the method which is the sort method. We can do that. We can do a static import on this sort method also, or on the global like the star. We can use wildcard. So that is fine, because that's why we are selecting B as the correct option. This is not going to work at all. This is not how you do a static import, and these three are not going to work because we cannot use static before the import. We use import and then static, right? So D, E and F are not going to work in this case. Okay, I hope that is making sense, guys. Let's move on to the next question, question number 15, guys. And question number 15 says, what is the result of the following statements? So we have a class test over here, public class test, and then there's public void print and taking a byte, and we are printing byte, and then there is void print index, and we are printing printing int over here, and there is this print float and this object. So it's related to something like method overloading, and this is one of the very popular questions regarding method overloading. And then there is some stuff over here. So by reading through the options, I would say the correct option in this case is E, and it will print int, object and object. Why? Let's understand this question. The argument on the line 17, if you see this particular line, this is a short type. Now it can be auto promoted to an int. So the print on line number 5 is invoked, because see, if you want to convert from a smaller data type, same type of smaller data type, like from a short to an int, it can be auto promoted by the Java compiler, but the reverse you have to do a typecasting. So if you pass in this short over here, it will be automatically converted to an integer. So that's why this method which accepts an integer is invoked. I hope that is making sense, right? Now the argument on line number 18, if you see the argument on the line number 18, just after that particular line, which is we are passing an true over here, which is a boolean. But the funny thing is that we don't have a boolean method over here which accepts a boolean overloaded method over here which accepts any boolean value. So what is the precedence that it will go? It will first try to match the exact type, otherwise then it will go to the wrapper type, and then it will go to the object type if it present, because object can hold any kind of types. So that is why it is gonna go to the object one. So int, first one is int because of the short, and then we go to the object because of the boolean one. All right. Now talking about line number 19, right? And line number 19, it says 6.789. Now the argument on line number 19 that you saw over here is a double, double, double. Now it can be auto boxed to a double. So print number, this particular object is invoked. See, this is a float type. If you pass in a 6.78f, like it will be a complete float in this case, then maybe this float method will get invoked. But as you are passing a 6.789 directly as a double, it will try to find out a double method first. As it is not present, it will be auto boxed to object type. So it will be accepted by the object type. It will not go to the float type because there is no double, or there is no double wrapper type. So it will not go to that. It will directly go to the object type that you see over here, object X. That is why object again is printed for this particular thing. Okay, so that's the output is int, object and object. I hope that is making sense, guys. Let's move on to the next question, question number 16, guys. What is the result of the following program? Okay, now let's read through the options, guys. It's a pretty simple question actually, and according to me the correct option in this case will be B. See, first of all, Java is passed by value. Okay, you cannot expect a pass by reference type like you do with pointers in C or C++, right? So Java is passed by value, and the variable on line number 8 never gets reassigned. This particular variable that you see, it never gets reassigned at all. So there is a 9, we pass in the 9, and then that is gone. That is gone inside the method, and that some kind of operation happened to that value. What I am saying, just keep a particular focus on what I am saying is the value is being operated on. The reference is still there. It's still the value, the value of value in this case is 9 only, if we pass the value over here inside the square method, whatever you do inside the square method doesn't matter at all, because this is passed by value. You are not passing a reference, this is just the value. It is similar as passing the value which is 9. We are just passing the variable value over here, but don't think that we are actually passing the reference of that variable. We are passing the value 9 only. It's a different case with objects. I have already explained that in detail in my previous video. You can have a look at that. But when it comes to normal primitive types, it's just the value that is passed. Okay. Alright, let's move on to the next question, guys. Question number 17. Alright, so question number 17, it says which of the following are output by the following code. It says public class string builders over here, and there is this static string builder work. It's a static method which is returning a string builder, and it's doing something, and it is returning the string builder from over here. And then there is this main method. We are creating a certain string builders, and we are passing these two string builders in the work method and some stuff, right? So I read through the code, and if I go through the options, I would say the correct options in this case are B, D and E. Okay, so S1 equals to S1, S2 equals to S2B, and S3 equals to A. That is the correct option. See, I just in the previous one I talked about like pass by value when it comes to primitive types, right? You just pass the value, you're not passing the reference. But when it comes to object types, or not object types, your reference type variables, like a reference to an object or something like that, in this case a string builder, there is a whole lot of different stuff happening over here. In this case, you can consider this as a pass by reference. Okay, you can go to the video. I have explained in detail how this kind of stuff happens with reference types. Okay, now assigning a new object to A, which in this case is this one, this A that is coming over there. If you assign a new object to that particular A reference, does not change the caller, first of all. Now when you call the append method, it does affect the caller, because both the method parameter and caller have the reference to the same object. Now what I mean by that is, see, when I pass S1 and S2 into this method, string builder A and string builder B, now S1 and A, S2 and B, these will be pointing to the same string builder object. In this case, you can take it as S1 over here and can take it as S2 over here. So any changes that I made, using the A will affect this S1. This particular object will get changed, and any changes made to B will affect S2, right? And this is the thing that where people get confused between the primitive type values, where we pass them as pass by value, and this is kind of pass by reference, right? The only I would say thing that differentiates this confusion is that we are passing this reference variable of S1 in this case, and it is being assigned to this particular A variable. Like for example, take this as per thing. We have a class A equals to new class, right? This is the thing, and then do a class B equals to A. That's the thing. That is the thing that is happening over here. That's why in this case both A and B are pointing to the same object. Okay, I hope that is making things clear. I have explained this in detail in my previous videos in chapter number 4. Please go to that. So in this case, if you see, first of all, S1 equals to S1, right? So that is the thing. Okay, so we pass in A over here, and we are assigning A equals to new string builder. We are not doing anything to the S1, the reference that was passed over here, right? We are doing A equals to new string builder. So what will happen, instead of pointing to this S1, this will point to a new variable or a new something like A over here, because we are assigning a new string builder over here. Okay, so we are not modifying the S1 that was passed into this method. That's what I am trying to say. Okay, now B dot append B. Now see, now what will happen, B dot append B. Now a B is appended over here, so we are not created another instance of string builder in B, right? We haven't done that. We just appended B to it, so it became S2B. So S2 equals to S2B. Now S3, if you see, S3 equals to, we are returning this one, that new string builder that we created with A, we are returning that. So in this case S3 will be A, I hope that is making sense, right? You know, it is a little bit difficult when I try to explain it in a question. Please go and watch the video where I have explained this in detail, guys. Please have a look at that. So question number 18, it says which of the following are true, and let's read through the options. Okay. Alright, so I would say in this case the correct options are C and G. Okay, now let's consider the situation. Okay, there is a class and we have a main method in that class. Okay, since the main method is in the same class, right? Let's continue. It's in the same class, right? It can call private methods in the class. Okay, because it is in the same class, and if you assign something as private, it is class private access. It means that anything that is present in the same class will be able to access that particular variable or method. So this that I'm saying, this thing that we are seeing over here may only be called as the first line of a constructor. Okay, because this is something used as constructor chaining. If you want to call another constructor from another constructor, then you use this particular thing. I hope that is clear. Now this dot variable name, this thing that you see over here can be called from any instance method to refer to an instance variable, right? So that is fine, you guys got it. It cannot be called from a static method because there is no instance of the class to refer to. Static method is particularly associated with the class only. Okay, you cannot call it from a static method. Non-static method can call static objects, but that the reverse is not possible. I've already told you. Okay, now option number F is a little bit of tricky. The default constructor is only written by the compiler if no user defined constructors were provided. So this that you see over here, that we have written over here, this particular thing can only be called from a constructor in the same class. Since there can be no user defined constructors in the class, if a default constructor was created, it is impossible for option F to be true, right? So I hope that is making sense, guys. Let's move on to the next question, guys. It's a little bit of tricky. It's fine. You have to be very much of careful with the concepts, then only you will be able to answer this question, but it's fine. Practice makes, perfect. Question number 19, guys. It says which of the following classes compile and use a default constructor. In this case, I will go with the options A and G. Now options B and C don't compile because the constructor name must match the class name. So we are just gonna ignore option B and C altogether, right? Since Java is case sensitive, right, these don't match. All right, so that is fine. We got that. We got rid of that. Options D, E, and F all compile and provide one user-defined constructor, right? They provide one user-defined constructor. Since a constructor is coded, a default constructor isn't supplied. All right. Now option number G, it defines a method. Now this is where it comes tricky. People think that this is a constructor, but that is not a constructor. If it had been a constructor, then there is no requirement of this void over here. So don't get confused. This is just a method. Option A does not define a constructor at all, so it will get the default constructor. So all other options are not going to get any default constructor based on the reasoning that I made just now. Okay, I hope that is making sense, guys. Let's move on to the next question, question number 20. So in question number 20, what it says, which code can be inserted to have the code print 2? So what can we insert in line number 1 and line number 2 so we can print 2? I think I don't know, that is the question, right? All right, now if I look through the code, I would suggest that the option in this case will be E. Replace line 1 with this dot 2, sorry, this in parenthesis 2. Why is that? Now option A and B will not compile because constructor cannot be called without the new keyword. So you cannot use it like this, right? You have to use a new keyword, new constructor. So use a class name, object name equals to new class name, and then you provide the parenthesis, right? That is basically calling the constructor. You have to use the new keyword. So A and B are not going to work. Option C and D will compile but will create a new object, right? This is what I was talking about. It will create a new object in this case rather than setting the fields in this one. Okay, Now option F will not compile because this must be the first line of a constructor. We cannot use this over here. If you are using this, it should be the first line in this case, but it is not in this case, so we cannot use it in line number 2. So F is also not going to work. The only option left is replace one with this 2. So if I replace this as this 2, what will happen is that there is another constructor over here which accepts an integer parameter, so it will just call this constructor, and this dot number bags equals to number bags will be set, and we will get the output as 2, right? I hope this is clear, guys. Alright, let's move on to the next question, question number 21. Alright, so question number 21, which of the following complete the constructor so that this code prints out 50? Okay, so it says public class cheetah, then there is this instance variable in num spots, and then there is this constructor, and then there is this main method, whatever, and this is it. So we have to choose all the options that apply to this thing. Okay, so by going through the options, I would suggest that the answer for this question is option number C, which is this dot num spots equals to num spots. It's a pretty simple question, guys. So basically what we are doing is, this is our instance variable, and this is the variable that is coming in inside the parameterized constructor. So as both the names are same, we have to differentiate between the instance variable and the local variable by using this dot num spots equals to num spots. Okay, this is pretty easy, guys, pretty simple. Let's move on to the next question, question number 22, and it says what is the result of the following code. So we have a public class order, then there is a static string equals to a null string, then there is this this is initialization block, normal initialization block, and then there is a static initialization block. Alright, then there is another normal initialization block, and then this order driver class, we have a main method, and we are printing order.result 2 times, and then we are creating 2 new objects of the order class, and then we are printing the result a 3rd time. Okay, so what could be the answer in this case? So in this case, I would suggest the answer of this question is E, which says UU and then UCR CR. Okay, now let's see, understand how this thing happen. Now if you see line number 3 over here, you know, of the, sorry, not this line number 3, my bad, this line number 3. If you see this line number 3 of this order driver class, right, we refer to the order for the first time. Okay, at this point the statics in order gets initialized, so the class gets initialized, so all the static variables and stuff that is inside the order class gets initialized, right? In this case, the static whatever statics are there are the static declaration of the result and the static initializer that we just saw over here, this one and this one, right? These two things have been initialized till now because the object has not been created till now, right? Now on line number 4, result is the same because the static initialization is only run once, right? So when we say 3 and 4 over here, order a result, we have U, and then we order a result, we have U only, because static block only gets initialized once when the class gets initialized. Actually every static variable and function or static initializer block get initialized when the class is getting initialized, right? So that's why we got this UU over here. Okay, I hope that is fine, you understand, because there is no change to the result string as of now, only 2 times we are printing U. So on line number 5, we create a new order which triggers the instance initializers in the order they appear in the file. Now the result is UCR. Okay, so the result is UCR now, because if you see there is this there was this U at the beginning, U, and then this static initializer block comes first, so a C is appended, and then this this normal initializer block comes first, so C is appended, and this one comes second because this one comes first and this one comes second, right? So then R, UCR is printed, right? So now it is called again, I mean the object is called again. Now again these two normal initializer and this instance initializer block gets executed again, because see, according to the rule, the static initializer block gets initialized when you create the class for the first time, I mean initialize the class for the first time. So static initializer block will not execute again, but the normal initializer block or the instance initializer block, it always gets executed whenever you are creating an instance of the class, because that is associated with the object itself. So after UCR, then again CR is appended, right? So when we take the result at the end, we get this string, right? So I mean U is already printed, UU, and then UCR CR. I hope that is clear now. So that is the correct option in this case, guys. So it's a little bit tricky question, guys. You have to be very careful about like what is the rule and what is happening and stuff. Other than that, it's pretty, you will be able to do it, okay? So don't worry about it. So this question, what is the result of the following public class order? Then there is this value equals to t, and then there are two instance initializer blocks which append some values to this value, and then we have this default constructor with which appends b to the value, and then we have this parameterized constructor which appends s to the value. I think that's fine. Then we have this main method over here, and we are constructing two objects over here, actually using the same reference variable to construct a different object, but yeah, that's it. And then we just display the order value. Alright, so by reading through the code, guys, I think the correct answer to this should be TACB. Why is that? Basically, if you have a look in this particular scenario, we are creating an instance of the order class, new order, and we call in this parameterized constructor, right? So whenever we initialize the class, create the object, these instance initializer blocks will run in order along with the initialization of this string value. So if value is initialized to t, then value plus equals to a, so it is ta currently, and then value plus equals to c, okay, and then this constructor gets executed after that. So another value gets appended, which is s. So TSCS is currently the result right now. But over, if you see in this particular line, order equals to new order, and in this case what we are doing is we are calling the default constructor, right? So what will happen is that obviously this is not a static variable, so this value will not get retained, right, because it is different for all the objects that you create. So currently the same thing will happen again. Value is t, then a, and then c, and in this case this default constructor b will be appended because that is called over here, right? So b will be appended, so TACB over here. This one s will not get appended because in this case we are not calling the parameterized constructor, we are calling the default constructor. I hope that is clear, guys. This is pretty much it. So TACB will be the answer. Let's move on to the next question. Question number 24, guys. Now which of the following will compile when inserted in the following code? Choose that, all that apply. Public class order 3, and then we have a final string value 1 equals to 1, and then static string value 2 equals to 2, then string value 3 equals to 3, and then we have this instance initializer block and then this static initializer block. What will we do to make these things compile? Alright, so if I go through the options, I would suggest that the answers to this question is B, C, and E. Alright, so why is that? So value 1 is a final instance variable, right? I have already we just went through that. So it can only be set once, so in the variable declaration or an instance initializer or a constructor. You cannot reassign it, but you can assign it at these places. You can declare it and then assign it again, but you cannot reassign it, right? That is the rule. Now option A does not compile because the final variable was already set in the declaration, so you cannot set it again, first of all. Alright, I hope that is clear. So option A is out of the question in this case. Value 2 is a static variable. Both instance and static initializers are able to access the static variables. We have gone through this many times. So both so option B and E are correct in this case because it's valid, right? Now value 3 is an instance variable. Option D and F do not compile because a static initializer does not have access to the instance variables. Now we know that let's take this example. We know that an instance method, normal method can access a static method, right? But the vice versa is not possible. Similar is with this case only. So that's why D and F is not going to work in this case. So answers are B, C, and D. I hope that is clear, guys. Let's move on to the next question. Question number 25, guys. And question number 25 says, which of the following are true about the following code? We have a public class create over here, and we have a constructor, default constructor, and then there's a bunch of overloaded constructors, and then we have these two calls to the constructor, we are creating the object of the create class. All right, I hope that is clear, guys, the question. So which things are true in this case? And if we see through the code, right, I would suggest going with A and let's see, E. All right, let's see why I selected these options. See, the 100 parameter that you see over here is an integer, so calls the matching int constructor. I mean the int constructor. I am talking about the primitive int, not the this int. So this constructor is getting called because see, what if you remember the rules, if you have an exact match in an overloaded situation, it will call that only, right? It's not that you have a primitive method, like it is accepting primitive parameters, and another one there it accepts boxed parameters. So obviously if you are passing in an int, it will give priority to the int parameter, right? I hope that is making sense to you. Otherwise you can go back and watch one of those videos. So this constructor gets called, that is fine, right? So when this constructor is removed, Java looks for the next most specific constructor. I've already discussed that. Now the 100L parameter is a long. Now L is long, right? So if you see, it can't be converted into a smaller type. So we cannot expect a int parameter constructor to accept the long. So what happens, it gets auto boxed to a long, and the constructor for object is called this particular one. Why? Because we don't have a capital long constructor, right? We don't have that, like a auto boxed constructor, but we have an object constructor which accepts anything. So that's why the code prints out 2 and 4. Now why E is correct? Code prints 3 and 4. If you remove the constructor create int num, now if you remove this specific constructor, so for 2 the next specific constructor is integer 1, so 3 and 4 will get called, right? I hope that is clear, guys. You have to be a little bit of more, you have to remember the rules, right? And it becomes easier when you practice more and more questions. So don't get flustered or don't get annoyed by these questions, right? Don't worry, guys, it's you will be able to do it. Okay, let's move on to the next question. Question number 26, guys. Now it says, what is the result of the following class? And we have imported some Java util function, I don't know, and there is this class panda. Oh, I like pandas. And then we have int age, then there is this main method, panda p1 equals to new panda p1.age equals to 1, and then there's this check, and it accepts this object, and I guess this is a predicate. It is accepting a simple lambda function predicate, and then we have this private static void check, and that is the predicate. It is coming, and we are testing this function with the panda object, and then we are printing the result, which is a string. Okay, now let's see what will be the result of this following class then, right? So by going through this options, I would suggest that the correct option is match. All right, and it's a pretty simple question, guys, because see, we are creating the object of p1. Now first of all, there is no compilation issues, because you have to first check that okay, this lambda syntax is correct. This is fine. This is a shortcut syntax of lambda, and it is just returning one value, so the syntax is pretty much of correct, and this ternary operator syntax is also correct. So you don't have to worry about these compiler issues or any runtime issues, right? So the only thing that you need to select is A and B. Now see, we are setting the age to 1, all right, and we are passing in the object now. Now in P1 the age is 1 currently, so that is fine. We are passing in, and we are passing this function as a parameter, which is a lambda function, to the predicate. So the predicate accepts a panda type, panda, and we have a predicate, and then there is this string result over here. Now in the we already know that in predicate we have a test method, abstract method, and you need to implement it, and this is the implementation that we are passing. So panda.test panda, so this panda that is coming is this panda where the age is 1, right? Just focus on what I am telling you. So when we test it, this function gets executed. So p.age is less than 5. Yes, it is true, because we have set the age to 1, right? So it returns a true value. so that this portion of the ternary operator gets executed. We get the match, and the result is a match. So match is getting printed over here. So that is the answer, guys. So from lambdas and stuff, you will get very simple questions, so you don't have to worry about very tough questions. You just have to see if the syntax is correct or not, and if the syntax is correct, you can go ahead and just go for the answer. Question number 27, guys. Now it says, what is the result of the following code? And we have an interface climb, and boolean is too high. There is this particular interface, and this, I guess this is a functional interface. And then we have this thing, public class climber, public static void main string arguments, and then we are this check method. We are passing in the implementation of this method, and dot is empty, and then we are passing in the limit, which is 5. I think that is the parameter. And no, this is the parameter for the check method, which is the height. Okay, this is the implementation that we are passing. This implementation we are passing for this parameter, and this 5 we are passing for this height. Okay, I think that is clear. Climb is too high, and something, and else there is something. Okay, let's see what is the answer for this question. So I would suggest for question number 27, I would go with C, which is compiler error on line 7. Now why is the compiler error over here? Let us try to understand this thing. So the interface takes 2 int parameters, right, first of all. And if you see, we are doing some appending. Do you think it is possible to append something to an int parameter? It's not possible, right? We cannot append something to the int parameter, and there you cannot even do as is empty check over there. So I think that's why compiler error is there on line 7. Okay, I hope that is clear, guys. Let's move on to the next question. Question number 28. Sometimes the questions are very easy. That's why I told you, right? Whenever you are going for this question where you have to deal with lambdas and all, you'll get very easy questions. First of all, you need to check if there is any compiler issues or not. If there are no compiler issues, you can go ahead and just do it, right? Now, which of the following lambda expression can fill in the blank? Choose all that apply. We have a list of string, and then it's remove if, and if you remember, remove if accepts a predicate. First of all, you should be knowing that, because we have discussed about this. So let's see what will be the answer to this question. I think the answer to these questions are A, D, and F. Okay, why? Because it accepts a predicate, it expects a predicate, so which takes a parameter list of one parameter using the specified type. So option B and C are incorrect because they do not use the return keyword, right? If you see, the syntax is wrong, that's why we are not taking this. And if you see, talking about E, if you see this particular question, if you are like specifying the return type, you have to do this, right? But that is not there, so we are not going to go with that. This is cool. This is because if there is no there is just only a single line and you are returning something, you can write it like this. And D is also fine because we are putting in the brackets and we are using the return statement with the brackets and then this thing, and then we have a semicolon, so it's fine. And F string, as I've told you, right, this is also fine. So that is correct, guys. A, D, and F are the correct answers. Let's move on to the next question. Question number 29, guys. Alright, so which lambda can replace my secret class to return the same value? So yeah, this is basically, that's why we are using lambdas, right? Because this thing, to avoid this thing, we are creating multiple implementation classes for a lot of interfaces. So to get rid of that, we are using lambdas. Alright, so what can be the possible solutions to this particular question? And if you look at the options, I would suggest the correct options are A and F. Why is that? Because see, first of all, option B is incorrect because it does not use the return keyword. Options C, D and E are incorrect because the variable E is already in use from the lambda and cannot be redefined. Okay, that is a rule. Additionally, option C is missing the return keyword and option E is missing the semicolon. So I hope these are all good explanations to the why did I not go for these options. Alright, guys, so that's all about this particular lecture. We covered a lot of questions from this part because a lot of questions will come from this section. So yeah, make yourself familiar with methods, encapsulations, constructors, and a little bit about Lambda, and you are good to go for this particular part, guys. Yeah, so that's it from my side for this lecture. I'll see you again in some other lecture. Till then, have a nice day. Bye bye and take care.